Hi everyone, in this video from Count Backwards from 10, we're going to take a quick look at the TEG machine, how it works, and how to interpret the readout along with what to do about the results clinically. TEG is a great tool in patients who are losing blood for purposes of resuscitation, predominantly used in liver transplants and traumas, but now getting more attention in fields like obstetrics and intensive care because it helps guide your resuscitation efforts. What the TEG allows us to do is look at our clotting cascade and see where we're deficient so we can pinpoint exactly our resuscitation efforts. So, as usual, I think it's important to define how the equipment works before we delve into the information that it gives you. But it will be quick and basic, I promise. So first up here, we're going to draw, this is going to be our transducer. It's going to take the information and convert it to the computer. There's a torsion wire that hangs, allowing it to spin and create torsion. Then there's a pin here, and this pin is going to get submerged into a cup here, that our blood sample is going to end up getting loaded into. Ooh, that didn't work. Sorry about that. Better to just kind of hand doodle it in. And so, what happens is, the blood, or the cup rather, is warmed to 37 degrees Celsius, because that's about normal human body temperature. And the cup oscillates, it rotates back and forth slowly, with the goal being to simulate venous blood movement. So now we have warm blood just like in the body, and it's kind of moving the same way venous blood would. Now, as the blood begins to coagulate, the pin that's submerged begins to stick to the clot that's being formed in the blood. So all of this is starting to now stick to the pin. And now as the cup oscillates and the blood moves, the pin submerged begins to move with it. And as a result, you get a measurement in which the amount of pin motion is directly proportional to the strength of the clot. Pin motion proportional to clot strength. This motion is then recorded and displayed on an output, and we'll discuss that next. As the clot gets thicker and stronger, the pin motion increases. Then after that, as fibrinolysis occurs, the pin begins to move less as the clot weakens. So now that we have an idea of how the machine works, we can start to take a look at the actual readout and how to interpret it. So I'm going to go ahead and draw a sample TEG reading here. As usual, I'm sorry that I'm not a good artist. I need to actually bring these so they're meeting. So there's 5 parameters we're going to go ahead and look at. There's the R time, there's the K time, there's the alpha angle, there's the MA or max amplitude, and there is the Ly 30 or the lysis at 30 minutes. And I'm going to go ahead and label them here. R time, K time, alpha angle, max amplitude, and Ly30. And now we're just going to go ahead and kind of discuss a couple of the parameters for each one of these, what normal is, what they mean, how to treat them, etc. So, what the R time represents is the time to first clot. Okay? And the normal for the time to first clot should be anywhere from 5 to 10 minutes. And remember, this is the first clot that's formed that can be detected by the machine. And as you would imagine, it's a function of our clotting factors. So we'll go ahead and say, clotting factors. And therefore, the treatment is going to go ahead and be FFP, because FFP has all of our clotting factors and we're trying to replace them in our patient. So a prolonged R time means it's taking too long to start our first clot, and these patients should receive FFP. Next, we have our K time, and this is the time until the clot reaches a certain level of strength. And this is at certain level strength, 20 millimeters. A normal time, 1 to 3 minutes. And this stage is dependent on fibrinogen, because as the strength of the clot improves, as it gets stronger, it's because that fibrin bridge is forming. And so a prolonged K time means that you're having trouble reaching this certain clot strength, and it should be treated with cryoprecipitate, because cryo has most of our fibrinogen. Third, we have our alpha angle, and this is the slope of the line between R and K, and it measures the speed at which of fibrin mesh formation. A normal angle is between roughly 50 to 70 degrees, and this part is also dependent on fibrinogen. And when you have an angle that's shallower than 50 degrees, patient should also then be treated with cryo. Our max amplitude, as you might have guessed, is our final strength of clot. Final clot strength, or max clot strength. It also helps to represent the overall stability of the clot. A normal value is about 55 to 70 millimeters. And if lower than that, represents a problem with platelets. And you should treat by giving platelets. And our last part we're going to discuss is the Ly30, or the lysis at 30 minutes. And we'll do this in orange. And this is the percentage lysis of clot at 30 minutes. A normal value is 0 to 8%. And if there's more lysis going on at this point, it means that you have increased fibrinolysis, and you should, so fibrinolysis, too much, and you should treat these people with Amicar or TXA, tranexamic acid, because this is going to help prevent further clot lysis. So that's our intro to TEG. In a later video, we will take a look at various pathologies and how they may affect our TEG diagram. As always, if you have any questions, please feel free to write in. Interested in getting involved or contributing, let us know. Otherwise, subscribe below and tune in for the next video.